One of the applications of an integrated transportation model is to estimate the benefits of ITS in traffic management on operations. The ability to capture the system response on both the demand and network side is essential and is difficult to achieve with a non-integrated model. Polaris allows the modeler to estimate benefits according to three goals: mobility, energy and environmental impacts, and reliability. To estimate the impacts of weather-responsive management strategies, a modeler can introduce multiple weather scenarios. To study the benefits of management strategies on the duration and impact of incidents, multiple accident scenarios can also be introduced. The traffic flow model in Polaris is sensitive to both weather and accident. The sensitivity is modeled by reducing capacity of network segments impacted by an event. An integrated transportation model and graphical user interface enables the modeling of the operations of a traffic management center. A modeler can observe the traffic conditions as the simulation progresses by using aggregate plots or through visualization of each individual traveler. A modeler can interact with the ongoing simulation and control ITS components as the simulation progresses. Here is a schematic representation of the simulation of a traffic management center. The user observes the traffic conditions and decides on appropriate actions which can be applied using the graphical user interface. In the following demonstration video, we show how Polaris is used to estimate the benefits of ITS on transportation operations according to mobility metrics. Mobility improvements measure the travel time savings and on-time performance. We will consider a subarea that includes the Chicago Business District and several adjacent freeways. This part of the network suffers the most from congestion. We demonstrate the operations of a virtual traffic management center that relies on multiple ITS components, such as variable speed signs. These control the speed limits at several locations on the network. Variable message signs are one of the two Traveler Information Services components used to provide en route information on incidents, road closures, and delay information. Highway Advisory Radio provides pre-trip and en route information on weather and traffic conditions. This radio signal covers the entire area. The response of travelers to information is controlled by behavioral models. Researchers can adjust the parameters of these models. The tow truck model can be used to estimate the impacts of accident detection, automated vehicle location, and computer-aided dispatch systems on the duration of the accident. In this case, tow trucks serve the highway system. The tow truck locations are simulated and can be visualized. Polaris simulates the impact of ramp metering rates on ramp queuing and highway capacity. The Alinea model is used to control the flow. The current state and the parameters of this model are shown in the Attributes panel. Polaris has the capability of modeling two major event types. Several forms of weather events may be modeled. These include rain or snow and take into account factors such as temperature, wind, and visibility. Accidents may also be modeled. The severity of the accident is indicated through the number of lanes blocked and the clearance time. Capacity reductions for these events were derived from the guidebook on the analysis of active transportation and demand management strategies. To estimate the benefits of ITS and management strategies for mitigating accident impacts, the modeler can specify accident events within the simulation. Each accident is specified by location, duration, severity level, and number of lanes affected. In this case, there are two accidents specified, depicted by the animated smoke particles. There is an accident on Lakeshore Drive, a local highway in downtown Chicago, and another accident on the I-290 interstate. Polaris can simulate network performance under different weather conditions. The modeler can define a weather scenario by specifying the part of the network affected, the weather type, such as snow or rain, the start time, and the duration. Notice the bars that show the impact of the snow on travel times. The weather is depicted using blue snowflake-like particles. This concludes this section on the benefits of ITS and traffic management on operations.